we have assembled amongst us the members of the PREMIS editorial committee. So Karen Bradenberg, who's the chair of the PREMIS editorial committee, Eld Zirao and Mickey Lindlar, who are also going to talk to us today. And you're here as a team, I mean, for lots of reasons, but we want to make a bit of a fuss about the fact that you were the winners of the Digital Preservation Award for the DPC's 20th anniversary in 2022. And in this workshop webinar, the team are going to give you an introduction to that award-winning work, to the metadata for digital preservation, to the PREMIS data dictionary. They're going to outline the PREMIS data model and all the semantic units that can be used for capturing digital preservation metadata. And this will be interactive. We want you to participate. I mean, we really think you will get the most out of this experience if you do. So if you can, there will be instructions about how to do that at the appropriate moment, but please do, because we do think you'll get, as I say, we'll get the most out of it. So I think that's it really in terms of an introduction. I don't want to talk much more. I want to hand over to the team and let them guide you through this. So Karen, I believe you're up first, so it's over to you.
Yes, I am. Thank you very much. Thank you for coming. I can see that we are quite a lot of number online for currently. I guess we will have as many looking at the recording afterwards. So I'm just going to dig in because you want to get into the nitty-gritty. So the purpose of this tutorial is that we are going to introduce PREMIS. As you understand, we have been working with PREMIS for some while, so this is an introduction. You will not be fully learned today, but you will have the baseline and a common understanding of PREMIS, and we will introduce you to the PREMIS community, which actually is rather big nowadays. As we already heard, PREMIS won the DPC Anniversary Award last year. You see that down on the right. But what we also want to celebrate with this webinar is that we do have a document called Understanding PREMIS that we are happy to be making available in different languages, and the latest one is in Spanish. So that's a really, really big thing for us to make sure that everybody can learn about PREMIS. Who are we? Well, all three of us are from the PREMIS editorial committee, and we know that the things that might be true today about you who are listening to us are, you have just started to know PREMIS. It's kind of scary. You might have been using PREMIS, and you usually comes from a library, an archive, or a university, but you might also come from something totally different, like a software vendor. So we are hoping to make it a little bit easier and not as much scary as it might seem. During the whole presentation, I want you to think about one thing. What will you be using PREMIS for? What is your use case? When you hear all of us talking about the different things, think about how does this fit into my setting? What can I do? You have an example on the screen, but that's just one example. You can use PREMIS for a lot of more things. We do have an agenda. We are going to introduce PREMIS. We are going to talk about the main entities and the data model. As we already heard, we have a full packed 1.5 hour. So we will see in the end about the questions. Otherwise, we will make sure that you all get answers to your questions. So, what won't we talk about? Since I said this is just 1.5 hour. Yeah, we will not go into super detail. We will not talk about the PREMIS OWL in detail. It will be mentioned. We won't go into PREMIS in maths, which is one of the most common use cases. And we won't talk about environments. You will get a hint of what the environments are, but we won't do any deep dives in anything of this. So let's start off with digital preservation metadata. Why do we need it? Do we need it? And what does it look like? So what we talk about is that we talk about the metadata that you need to have to make sure that the digital resources you have are long-term accessible. That also implies that these digital objects must be self-descriptive. And when we look at them today, we most certainly know that all the objects aren't really self-descriptive. We also need to be able to handle them in a system different from the one where they were created. Usually to do this and to make sure that we have all this information in a good format is using XML. Doing it correctly, a machine can read it, and also the human being can read it. And we also need to have more than one file to make everything understandable, so we pack it into an information package. So all these are different factors that we need to think about and make sure that we actually have when we talk about digital preservation. The domain we are talking about is not just the things that are born digital. You also need to preserve and take care of the digitized objects, because they need to go into and make a new life cycle. So remember that it's not just born digital, it's also for digitization. What you need to think about is the preservation goals and the preservation pyramid that Priscilla Kaplan made for us a number of years ago. It's still as current as when it was created. But you see here the goals in the pyramid and the means to reach the goals. So those are things that you actually can use for when you talk about digital preservation and why we need to do it. If we start at the bottom, we have the availability. We need to actually make sure that we have the objects, or that they are in a trusted, accessible repository, because otherwise we don't have the objects. We need to know about the identity. What is the file? We need to know either how to reach it. How do we identify it? What type and value? And those two will fall into place a little further on today. We need to understand them. We need to have metadata so we see the physical structure, how they are linked together. They might have a logical structure. And we also need to know where they come from, and do we need other objects to be able to understand this object? The list can be made much longer. This is just some hints of what we need to think about. We need to know that the objects haven't changed. So we need to know checksums. We need to know what functions we are using. We need to know the results. And we need to know which algorithms was used. It can be tricky if we don't know that, but we do have a way for preserving that. It also needs to be readable. We need to be able to look at it. We need to know about the medium. Do we need a really old PC to be able to look at this object, or have we preserved it and taken care of it so we actually don't need that old PC? Fingers crossed we don't need it, but you never know, you might be needing that. And we also need to be able to render it. That comes back to what I just said. You may be needing a new old PC, but you might have been, when you have that old PC, what software did you need to use? So you need to have all those things sorted out to be able to look at it. You also need to think about the formats. So a lot of things to think about. And the biggest thing, we need to know that the object is actually what it's supposed to be, that nothing has happened with it. And that becomes more and more important since there are actually bigger interest in getting hold of the old objects, for example, in court cases. So nothing has happened and no one has changed the history. So this is what we can use PREMIS for. All falls down to making sure that we know the object, that we haven't lost anything, that we know what has happened with it. So that's the thing to remember. PREMIS is here to help you. As I said, we also need to take care of the rights. So we actually need to make sure that we are taking care of and looking at them and of copyright on the licenses that might occur. You might have a license to use a software. Keep that in mind. So what is PREMIS? Well, it's a de facto standard for metadata. PREMIS means Preservation Metadata Implementation Strategies. We are, as you understand, an international team of members. The people talking today are based in Europe, but we also have members from US and also have had members from New Zealand. So it's really worldwide. And PREMIS has been used everywhere. So you might be using PREMIS without knowing it. The PREMIS standard itself is the data dictionary, which is where you will get the deep dive in today. We have an XML schema for aid, and there are an OWL ontology and a lot of supporting documentation. What are our activities? Well, we being in the editorial committee are the ones who coordinates revisions and implementations of these revisions into the standard. We do have an email list being at the Library of Congress. And we do some preservation metadata workshops like this one, but we also are present at iPress. So you can meet us in all different kinds of places. The scope is that we are a data model. Think about that. We are just a data model. We are not a ready solution. We are not something that you can go buy on the shelf and just say, I want to have PREMIS, and it's implemented. Right? And it can also be used by everybody. It's not just for archives and libraries, so everybody can use PREMIS. And you also can use PREMIS in the way, as you will understand later on today, in the way you need. You need to look at what use you will have of PREMIS and how you will use it. We have a number of online resources. That's where you mostly find us. And this long list, you will have availability to the presentation afterwards, so you will have all the links. We have a web page, we have vocabularies, we have the ontology. You can find tools that implement PREMIS on Copter, and we do have presentations and other material on Zenodo. And with that introduction, and also remembering you about the email list, it's active in different seasons, but all the information we send out comes on the list and also on Twitter and Mastodon. So with that, I'm going to hand over to Mickey.
All right, thank you. And this is the time in the agenda where I get to do a brief sales pitch for PREMIS. If you're already thinking, ooh, that was a lot of information. So why should you care? What is PREMIS good for? PREMIS is implementable core preservation metadata. And if we pick that apart, what does that mean? It's implementable by being rigorously defined. It's supported by guidelines to ideally be integrated into your automated workflows, but it can also be used in manual workflows. And in that, implementable state. It's technically neutral. What does that mean? It means that premise itself makes no assumption about what kind of technology, what kind of strategies you use. For all intents and purposes, and we will go over this a little bit later today, you can capture premise in XML and RDF, but you could also write it on a napkin if you're so inclined. And it's core preservation metadata, core, by saying that it's core information. It's what most preservation repositories will need to know to preserve materials over the long term. And it supports best practice and all the preservation principles that Karen just walked us through. So to make this a little bit more tangible, imagine that you want to exchange information about the same object with 3 friendly repositories, or even with 3 different technical silos within your own institution. And you all know that you have handle as an identifier implemented, but you use it in very different ways. So some repositories might store handle in a variable called ID obj, some store it in HDL, and some separated by ID type and group ID. Essentially means all the same things, but it's really hard to map these concepts together. So in comes premise as a sort of lingua franca that you can use to map the different implementations to the same meaning, either by native premise implementation, as shown here in XML or RDF, or just through a mapping means of things. So that will be interoperability through implementable preservation metadata. To give an example about the core preservation metadata, premise allows you to answer a lot of questions about any digital object that you have in your repository. And with that, it allows you to capture what you need to know about the digital object, not only today, but also in the future. And that is not just things like what is it on a descriptive level, but also what is it on a technical level. For example, how was it created, but also what has been done to it and what are you allowed to do with it. And those are 2 very different things. And lastly, it is de facto standard for preservation metadata, as it says in the data dictionary itself. It's things that most working preservation repositories are likely to need in order to support digital preservation. You can use it as a benchmark. It's a valuable resource to tell you what it is that you need to know about your digital object. It can be used as a method to model the information that you need, but it can also be used if you have already implemented metadata to identify your gaps. And with using premise, as Karen said, comes a great community of users with good resources that are ready to help you along the way. And with that, I hand over to Elt.
Thank you. Now we will look a bit more on the premise data model itself. And keep in mind that this is a data model created by the community experts in digital preservation. So it's just a lot of information that a lot of people knowing this field have thought should into this data model. You see the model here, and it is just for convenience that you have this model actually, so you can structure it. It's not meant as a data model that you implement in a database. It's meant as a way to look at it structured. So what does the data model include? First of all, it includes these entities, which are things that are relevant for digital preservation. I will tell you a bit more about that in a minute. Then there's the semantic units, which are the detailed information about each of the entities. And you also see these arrows, which are the relationships between the entities. So it's these 3 things that the data model includes. Okay, let's look a bit into the entities. So we have the object, which is what you want to preserve. There are different types of objects, and I will explain that in a minute as well. You can see here examples of what an object can be: a PDF file, an image within a file, a book or book representations. And even here, you can probably guess that there are these different types of objects. The implementation choice is that you don't need to implement all types of objects. So bear that in mind. Okay, so what is this type of object? You should see this as a premise, a file object. So it's telling, giving metadata about this file, which is a named ordered sequence of byte that is known by an operating system. There can be more files, of course, and these can form a representation. For instance, here you have a representation that points to these two files, and what it is. And this is actually a book, and it could also be another representation, for instance, an EPUB version. But the intellectual entity is a book itself with different representations. Okay, the fourth one, which is not in this example, is that you can also point to, for instance, an image within a page, which is called a bit stream. The event is an action that involves or impacts an object or an agent, and it's mostly to document the provenance needed to track the history of an object. Examples can be that a validation event, for instance, using Jehovah, or it can be an ingest event or many other events. The implementation choice here, you should also note that not everybody wants to record all events. So it's up to you what kind of events you want to actually have metadata for. And also the granularity of the events is up to you. The third one is the write, and that's in order to be able to preserve metadata about what rights that are to different objects for which agents. Here's an example that a person grants some permissions to a repository. And there are different implementation choices here. You can either use a PREMIS form, which I'll tell you about a little later, or you can also choose your own way of doing it. The last one is the agent, which is a person, organization, software, or system. It's just intended to identify an agent, so you can actually link to this agent. It's not that this is very detailed, but we will see that later. Examples is John Smith, which is a person, or IPC, which is an organization, or Jehovah, which is a program. And again, there are implementation choices. You can use rigid schemes, or you can just have the identifier. So if we take a digitization example, you have a premise file object where you have the different information about the file. You can have an event, which is actually the creation, the digitization of this file. And you can have this event is carried out by an agent. It could be Karen that actually performed this digitization. So this is the different things, and you've now heard about the entities. But before we move on, and you have to remember that we have these 4 different types of objects, but otherwise it's only 4 entities. But now it's time for a little exercise. So go along, Karin.
Exactly. I'm taking over the screen and I'm going to get you become active. So in the chat, you now have the link to this Menti. So you have now heard Eld talking about the different object categories. What you will be able to do in this Menti is that you have a pin that I want you to drop on a file object. So drop your pin on a file. We can see a lot of things happening on in the sort of the third quarter of the screen. And if you remember what Elle said, she was talking about representations and files, and we have the intellectual entity, and we might have a bit stream. So this is the things that you need to think about and look at when you are starting to set up your use of premise. Which type of objects are you going to describe? And I know Elle will be talking more about this in just a couple of minutes or seconds. So I'm not going to hang along too long. We can see that a lot of people are in the third section. And if I just press here, you can see that the file objects was all the things that were in that section of the image that Elle described for you. So that is the different file objects. And with that, Elle, I'm going to give you back the screen, but do you want to say something about the different objects once more? Just a couple of words, perhaps?
Yeah, but I think I will get back to it in a minute when we go back to describing the types. I see most
Perfect.
of you has actually taken the right one. That was a TIFF P1. That was a premise file objects. But you will see more just in a second. If you unshare, yeah.
Yeah.
Yes.
You take over again, Elle.
Yeah. Right. So now we will dive a bit more into the details, because now we will look more at the semantic units. We also have the relationships left, but they will come later. So semantic units. Semantic units is a piece of information that a repository would like to express or can express for their digital preservation functions. There are two types or two kinds of semantic units. There are either a container, like the object identifier, which group together related semantic units. And they could, for instance, here be two semantic components, which can actually contain the values. So if we look at the semantic units of the object and dive into that, they are to describe all the things we want to know about the object. For instance, the technical information, is an identifier for the object, what kind of object, is it software, hardware, is a certainly preservation strategy, etc., etc. And here are all the top level semantic units for the object. You always have to specify an object identifier and an object category, and I will explain that in a minute. So we already seen that the object identifier has a type and a value. So this is all the down to the bottom level for the object identifier. So if we go back to our digitization example and we look at the object file and its identifier, we would have to look up in the data dictionary. How does that look? So you can see it here. We go into it and we go down to the page with the object entity where it's described. And then we move further down and we can see description, or at least a line out of the different semantic units. So here you see the object identifier, the category, etc. But we are focusing on the object identifier, and here we can see that it has a type and a value. Already here you can also see more information, because this M is actually saying that an object identifier is mandatory. It's not optional, then it would have been an O. And it's repeatable, so an object can have more identifiers. If it had not been repeatable, it would be in R instead. Okay, if you drill further down, you have a more detailed description of the object identifier. And you can also see that the information that I just told you about is also represented here. But there's a lot of other informations. And if you go even further down, you can also see detailed description of the object identifier type and the object identifier value, also with examples, which can be helpful. Right. So for those of you who don't know XML, don't worry. You don't need to know XML to use PREMIS. This is just an example that can help people that know XML and can see how this could be expressed in practice. So we have the digitization example, and in XML, you have a premise consisting of object, event, agent, rights. So you can write it like that, as you see here to the left. But we didn't have rights specified in this example, so we just take that away. But we have agent, which should contain the information about the agent, and information about the event goes into the event tags. For object, there comes in again the type of the object. And there goes in the information about the object, where we also want our identifier, which will look like this. And as you can see, we saw from the data dictionary that we had object identifier, which is a tag surrounding other tags here, and you have the type and the value represented. So that was just a small example in XML. Right. If we again look into this type of object, where we here have a file, that is actually what's called the object category. So it has many names: kind, type, category. And that is not a tag in itself, as you saw. It's actually a XSI type when we're talking XML. It doesn't matter if you express it in any way, just forget what I just said. But at least you need to express somehow what type of object that you have. And it could be intellectual entity, it could be the representation, which could either point to different pages or the EPUB, and it can be a file, and lastly, it can be a bitstream. Right. If you wonder how could I see that in the data dictionary, maybe you noticed that in the object category here on the object identifier, there was an object category that has these different types and says whether it's applicable, repeatable, and so forth down. Right. Object characteristics. That is something that is mandatory for file or bitstream because they have some technical properties, but it's properties that are technology agnostic. So we should think that it does apply for all file formats. We haven't found any that it doesn't apply for. Object characteristics is a lot of different semantic units, and I will go in detail with some of them and explain the rest. For instance, composition level. Composition level is because you can have, for example, gzipped files where the file in the gzipped package has some characteristics that you want to express, but the package itself also has characteristics that you want to have metadata about. So for the most inner level, you always have composition level O. So if you don't have any packages, it's always level O. And then the next level would be level 1 and so forth. It's not just when you package things, it can also be mail attachments or images within PDFs, for instance. Right. Fixity, That's your checksum, your digest. So the checksum that you want to calculate for the file, so you're sure that it hasn't been tampered with. Size is size of the file. Format is format of the file, and that can be either be with a link to a registry, or you express it in any way, other ways. You can explain the creating application of the file. There can be inhabitants, like for instance, if it's encrypted, that you can specify. And finally, you can come with some extra detailed information about the object in an object characteristic extension. I'll explain a bit more here. So it's a container which can include external information which are not specified by PREMIS. For instance, to get more granularity, it could be technical metadata, for instance, and we will see an example here. So we have the object, and in the object characteristic extension, we have included a mix schema, which is a schema for specification of still image technical data. When you see this name extension, it will be absolutely the same thing. It will just be belong to another place, but it's meant for something that extra you can include. Right. Here I just put a small all example just to say, because I've just showed you a lot of XML, but that could be another example of how you express your premise. And it doesn't have to follow all or XML either. The most important thing is to follow the data model and have the pieces of information that is described in premise. Okay. Significant properties and a lot of other things that's more general info that I will go through in the same way. So significant properties is if you, for instance, want to make sure that width and depth in an image is preserved, then you can specify it there. Preservation level, I have to explain a bit more. That is actually, it's actually a business rule for what is relevant for a repository, and it can vary from institution to institution. It has different sub-semantic units, and it could, for instance, be about the bit safety level that you want for your material. Or it could be your logical preservation strategy. For the bit safety, it could, for instance, say I want a high bit safety level. And for the logical strategy, it could be, for instance, migration. It could be also specify a role. We don't do that, but it could do that. And you can also add a rationale if the given preservation level is different from the policy, for instance. And then, of course, the time of assignment must be specified. Okay, original name, that is if your file had a name that you think is worth preserving as well. It may change name for different reasons on the way. So here you can record the original name. Some repositories also want to point to the storage where the object is stored. Again, that's up to you. We don't use it, but I know a lot of other repositories do. There can also be signature information, for instance, if files are password protected. So that was the more general information about objects. You may think that this is a long thing, but since we are not going in depth with the environment, I can say that these 5 I will not go into detail with. However, I will give you a small example of what an environment can be. And I can also say that you need environments, for instance, if you want to preserve computer games, it may be very necessary actually to specify which environment they've been in order to emulate them later. So here you have a file content object, which is represented by an intellectual entity for the file. We can also have an intellectual entity for hardware, which is hardware that is required in order to actually render this file. And it can also require a specific operating system in order for rendering this file or to emulate this computer game. So now I won't say any more about environments, except that you can also think of this operating systems having a file which you also want to preserve. That's why it's not a special type of object, because an object can both act as an environment, but it can also be an object just at the same time also be an object for preservation. Right. Now we have these three left, and I will take them later after taking the other entities. So going to event, you see here that there are actually three things that are mandatory for the event. It's both the identifier, the type, and the date and time. An event must be related to one or more objects, and it can relate to one or more agents, but the objects are essential here. The event identifier is like for the object identifier, it's just saying event instead of object. It's a type and a value. The type of event is can be a lot of things, but I would recommend to look into the ID log.gov vocabulary first to see whether it's covered there, because then you can use it that value, but you can also define your own. And granularity is indeed implementation specific in this case. But it is to say, is this event an ingestion, invalidation, a fixity check, or and so on. Date and time says itself, the date and time when the event took place. Event detailed information is actually a kind of extension of the event, where you can put extra information about the event to describe the event. The event outcome is also like the extension, where you can include other schemes, so you can actually represent the outcome of the event. For instance, if you run Jeho, it will have an output, and you can put that in there. Now there's again some linking, entity linking, which I will go back to later. So that was the event. Now the agent, which is even simpler. We have only the identifier as a mandatory semantic unit. Again, type value, like all other identifiers. An agent can grant or rights, for instance, or it can carry out events on different objects, as we saw earlier. So the identifier we spoke about, the agent can have a name, the agent can have a type, and just to repeat, an agent can have the type of either being hardware, organization, person, or software. Again, here there is a vocabulary for these, but in this case, I would say you should stick to the values from this vocabulary. You can also put in an agent version, or put a note, or extra information in an extension using another scheme. And again, entity linking, I will take that later. And the last one is for environments, so I will not go into detail with that. Okay, the last one, rights. A premise rights can either be a right statement, which is the premise suggested way of doing it, or you can do it by a rights extension, where you can use any other rights scheme that you prefer. You have to take either the rights statement or the rights extension. You cannot mix them, must be one of them. If we look at the premise way, there is an identifier like any other identifier. Then there's a right basis, which is connected to the next four, because the rights basis can be copyright. And if it's copyright, then you use the semantic unit for copyright information, and so forth with license, statute, and other. If you want to have more than just copyright, you want to repeat it, you have to repeat a whole rights entity. You cannot put them in the same rights. And here just an example where we just have the name of the semantic units and the values. You can see here for copyright where there's status, jurisdiction, determination date, note, and documentation identifier. Then there's, of course, rights granted, which is to say what action is allowed, under which condition, and are there any time constraints. It contains act, for instance, migrate or modify, what the restriction is, a term of grant and a term of restriction, and a granted node. Finally, there's again this entity linking, and now I will tell more about it. So we take just these two and look at just these two from the rights. And for the agent, we go back and we also take these two, and so forth for the event. For the object, we just need to remember that we are still missing the relationship. So we haven't quite finished with that yet when we've gone through this. But we just take the linking here. So if we go back to the data model, the way that they are related is via identifiers. If we split out the arrows, so one going one way or one the other, we actually have for the object that the one going from the object to the right statement is a linking right statement identifier. And the same for the linking event identifier that points from an object to the event. And that's exactly the same for all the others. So these two semantic units for each of the entities are just links, how they link to the other entities. Okay, then we had this object relationship. That was the last one that we needed from the object in order to describe it all, excluding environments. If we go back and think of these four different types of objects, we had the intellectual entity, which was the top level. We had the different representations of an intellectual entity, which could have files beneath it, and there could be bit streams of files. For all these types, objects of intellectual entity can be part of another intellectual entity. And that's the same for representation, file, and bitstream. When we look up, you have that a bitstream can be included in a file. And a file can be included in a representation, but we don't go further up than that. But you should note that a bitstream, if you don't want to implement the file object, for instance, you only have bit streams and representations, you can actually have that a bitstream is included in a representation. When we come to intellectual entities, it's actually representing. And here you can see it doesn't matter whether it's a bitstream file or representation, they all can represent an intellectual entity. And again, that is to make it possible for you to exclude some of the types if you don't want to have them to specify them in the way you use PREMIS. So it's just different ways from one object to another to link up to each other, giving the hierarchy of the types. If you look into the data dictionary, you will see it in the form that I just showed in the right top corner here. But it's the same model, it's just drawn differently. Okay, so the semantic units for the relationship for objects will usually consist of a type, a subtype, and an identifier to the related object. If we take, for instance, an object that represents an intellectual entity, the type will be structural, the subtype will be represents, and then it will be an identifier of the intellectual entity object. So that's a simple one. There is no rule without exceptions, and we have the exception where it can actually be an event that also is related to the relation between two objects. For instance, if one object, for instance, a file, is migrated to another object, for instance, another file, then we should be able to point to that event and saying these two objects are related to this event. And it's only when there are two objects involved. Otherwise, you would use linking event identifier, because that would be from one object to one event. The rest of it has to do with environments, so I will not cover that more here. Okay, almost there. The only thing we are missing here is one of the semantic units you've seen before, but it's to do with environments. So don't bother about it. So this completes the data model.
Okay. So after that quick deep dive into the data model, and I think we're doing really well on time, I'd like to take a step back and again, give you some examples of how we can use PREMIS, and in particular, talk a little bit about PREMIS conformance and repository interoperability. And they've already been a couple of questions in the chat about that, so I'm happy to see that. Okay. So the PREMIS conformance statement is linked above here, like everything else. You can find it on the PREMIS maintenance activity website at the Library of Congress. And the conformance statement might feel a little bit like the OAS statement about OAS compliance, but I'd like to think that it's a little bit more concrete than that. There's some baseline assumptions. So baseline requirements in the PREMIS conformance statement is that for every entity that you choose to implement out of objects, events, rights, and agents, which Elle just introduced to us. So for everyone that you choose to implement, when in the data dictionary, it says that a semantic unit is mandatory, then you have to capture that. Like Elle showed you earlier, there's a handful of mandatory elements, so you don't have to implement the entire data dictionary. Also, for those levels of object that the repository supports, then you in particular have to capture those mandatory semantic units. So in the earlier exercise, you saw that there's intellectual entities, representation file, and bitstreams. If your repository chooses to support all four of those, then you have to support all mandatory semantic units for those. If it doesn't, then you don't have to. There's even off-the-shelf systems that do not support intellectual entities, but start at the representation layer, and that's legitimate. There's some other shared requirements. So if you have a shared name, then you have to have a shared definition. That means if you call something identifier within your metadata, then it should capture an identifier and not, let's say, a fixity or a checksum. If you have a shared definition without a shared name, then you need to have documentation to be conformant. And I will go into a couple of examples about that in a bit. The conformance levels document shows 2 basic classes and then 3 levels, and the levels can be reached for each class. Class A means that your repository only chose to implement the object entity, which is legitimate. Level B, or Class B, means that in addition to object, you chose to implement events and agents, which are closely connected, and I'll get to those in a second. And then for each class, there's 3 levels. The very basic level would be level 1, which means that you just have mapping. So you've achieved some kind of internal mapping that you've documented where you say, this is my metadata tag, my descriptor, and it maps to the following semantic unit of the premise data dictionary. So you don't have to call it the same within your metadata schema as you have. It doesn't make any assumptions about your technical implementation and so forth. You just need some documented mapping. Level 2 then takes it a step further. In addition to having the mapping, you have implemented some kind of tool or process-supported routine that allows you to export your internal metadata definition to something that is actually called PREMIS and documents PREMIS. And level 3 would then be the full implementation, so the native premise implementation, which can be in XML, in RDF, in JSON. It can be in a lot of things. It's important that the semantic units are labeled the same way as they are in the data dictionary. And of course, quite logically, the higher the level, the higher your degree of interoperability. But it doesn't mean that level 1 mapping is not premise conformant. That can still be premise conformant, just as at level 1. To give a couple of examples of what's conformant and what isn't. The screenshot up on the right hand with object identifier and M and R is taken from the data dictionary. So M means that it's mandatory, we have to have it. R means that it's repeatable, so you don't just have to have one. So let's look at some examples. 2 things that you cannot have is to capture none, because if you want to be conformant, you have to, like I said, include everything that's labeled as mandatory in the data dictionary, and none is just not there if it's mandatory. The other example would be to have something that has a shared name, but a different definition or a different information object that's captured. For object identifier in FMT18, FMT18 would be the persistent unique identifier of the file format. So it would describe the file format and not necessarily the identifier of the digital object itself. So those 2 would be non-conformant. Everything else that you see would be conformant. Let's start at the one at the bottom, premise object identifier with type and value. That would be, there's typo in there, see? That would be level 3, because aside from the little typo that I have in there, it's actually fully a full implementation of what is stated in the data dictionary. Then the one with DC identifier shows that it's repeatable, DC for Dublin Core. You could have an internal mapping, most likely automated, to map that to premise object identifier, and then that will be level 2. And the uppermost ones, eindeutige Bezeichner, which will be a German word for unique identifier, or DOI, could also be achieved through documentation, mapping, or through export. So now, when you start out, you might ask yourself, which entities do you want to implement? Like I showed earlier, there's 2 classes, Class A and Class B, and object is the core entity, level A. So of course, it doesn't make sense to have premise without saying anything about the digital object. That's the thing that we want to preserve, right? So that's the absolute minimum that you have to have. Events and agents are closely related, so they're both tossed into level B. Implementing agents has a strong implication. It allows us to tell what has been done to a digital object over the course of its life cycle. So let's say, take the example of fixity. Within the object entity, level A, we can store as the fixity as a semantic level or a semantic unit for the object or a file. But in addition, if we chose to implement event and agents, we can capture with what tool the fixity was generated and when it was generated and by whom, possibly for what reason, if it was generated during transfer at another point in time. So it gives us a whole other level of knowledge about a digital object. The rights entity is currently excluded from the conformance statement, but it helps a repository to track intellectual property rights, but also some institutional policy information like what you are supposed or allowed to or supposed to do with a digital object. With that, PREMIS can be used as a basis for other standards, for example, locally defined metadata. And if you have the slides later, there's a great example here by the Netherlands Institute for Sound and Vision showcasing that. It could also be used as a self-assessment tool with conformance level 1, where you actually see if you have all the provided information deemed mandatory that you're required to have to be able to answer that information about digital objects in the long term. It can be used as an export format in level 2. For example, if you want to have a PREMIS endorsed expression in XML or RDF that you want to export to, or to be used as a native format of a repository data management module with a full native implementation. And so again, give some examples. Let's think about the checksum example. So here's 2 implementations in RDF and XML that actually capture the same value and the same thing. Both are a SHA-256 value that is generated and stored in a PREMIS native form down here. And on the other screen, we see the same example in CSV or spreadsheet. The top levels actually will be an invalid CSV even because there's a semicolon here, but that's just a side note. But both would be legitimate PREMIS implementations. So you can start out by with PREMIS by just taking what you already have in your repository if you don't have a full PREMIS implementation, and kind of check if you have everything that's mandatory in the data dictionary, see if it's already there, and then you can easily identify the gaps, gather what else you need to capture, and then move up towards the conformance chain through that. And now it's time again for another Menti to check if you have followed or been able to follow my ramblings, that is.
Exactly, and it's the same link as before. So, and it's exactly the same Menti, so I'm just going to show it. So, with what Mickey just showed us, are these identifiers on the left side, are they conformant or not? I see the middle ticking a lot here. So, Mickey, can I get some aid here? We have a few responses to the middle one being not conformant.
Yes.
As being not a DC identifier.
All 3 are conformant as PREMIS values. They capture an identifier. What could be said on a semantic level, I think what possibly led to confusion in the second one is that it doesn't clearly state that it's a DOI type, but within the scope of PREMIS, it would still be conformant because you could have a documentation on the side that says that your DC identifier captures a DOI. So all 3 are conformant from a PREMIS point of view.
Going to click here to show that it actually is like that.
Yeah, and it's exactly what Leila is asking in the chat. How do you capture the nature of the identifier? If you would map that, the second one or any of them towards well, let's do the second one because it's a DOI, to a full PREMIS implementation, you would say that the identifier type is DOI and the value would be what is included as the value here, so 10.5281.
Many thanks, Mickey. And you have been having a full packed, a little more than an hour, so I will try to wrap all things up here, repeating some things that have already been said. But yeah, in the Menti, if you use the same link, you have now a question of what would you use PREMIS for? So you can answer that while we wrap this up. So you have the data dictionary, and to the question we have on the in the chat we have a specific question in the chat regarding what elements do I need to use if I use the event type and have given event outcome detail. You need to look into the data dictionary to actually see which semantic units you need to use. So look into there and see if it's optional or if it's mandatory, and that is what will guide you on how to create your specific event example. You also have in the data dictionary, you have a lot of more things than just the elements. If you take the full document, you have a lot of more text that you can read, and you should look at it. Also, I would encourage you to look into the understanding PREMIS to get a more sort of quotation mark lighter version to read. But everything is in the data dictionary. That's where we have given all the text. And as you have understand during today, you can implement PREMIS in many different ways. Among the other information, you have the identifiers that we have been talking a lot about. They are actually the keys, as you saw from what was presented by Eld and also what Mickey presented. They are the key to be able to do and link objects and make sure that we know which our objects are. So where and what? You have already gotten the link in the chat. The biggest resource is our webpage. From there, you have links to all the other places that we are. You have the email list. And as I said in the beginning, this is just an introduction. This is just the beginning of your travel into digital preservation with PREMIS. I'm already sure that you do digital preservation, but it might be your first glimpse of PREMIS, and PREMIS will aid you on the journey ahead. The resources, as I said, understanding PREMIS is a 30-pager on what PREMIS is, kind of the written thing of what you have been hearing today. Really not covering or making it easy accessible. And as I said, it's available in many different languages, like from now in Spanish. There is a PREMIS in Maths guideline, which has been giving how you should use these tools together, because when it comes to the digital preservation and the information packages that we all know about, PREMIS and Maths are often, or most cases, used together. And we have written, the two committees together have written a guideline on how you should think and how you should do it. And it's no difference. You can do it in different ways. You can split it upon the different entities, as Eld has described it, or you can describe the full PREMIS objective, and how you should place them and how you should think are described in there. You have already heard about the conformance statement, and there are some examples of implementation. So use the web page as your starting page. As I said, the understanding PREMIS in Spanish, I'm not going to pronounce this correctly, but entender PREMIS. gives the same text in Spanish. So we are really happy to have that available now. We also have it in a number of other languages like Czech and also in Brazilian Portuguese. So many thanks to everybody who have aided us with the translations. The current activity we do is that we are moving the data dictionary in a slow pace into a TAFE format to make it easier to maintain and transform to publications. So it will be available in many more different ways of showing it. So it will be a web-based publication and also the PDF. It takes its time. As you see, it's a lot of pages, so it's some work going on. The data dictionary will also, of course, being updated with the input from the ontology work. So that is also ongoing. And we are looking into enhancing our use of Zenodo, because since Zenodo gives you really great opportunities of how you save and store your presentations, that is what we are doing and moving things over there. We are setting up a new wiki, which will make it easier for communication between both us and all the users, but also among users. So that is also ongoing. And the rights is also getting an overhaul. So we are looking deeper into the rights to make it even more usable and make sure that we cover all the different examples. You might have heard a different number of presentations regarding the rights. So it's a really ongoing work and interesting work where we will be asking for input. There is a book, it's a couple of years old now, but there is a book named Digital Preservation Metadata for Practitioners Implementing PREMIS that gives the different use cases of using PREMIS in the sectors of museum, archives, libraries. So that's still a really good resource because it doesn't deep dive, it gives the information you need and really enhance your knowledge on when you should be using it. So please take a look. I would say that's something you should have on your bookshelf. And as I said, today has been really filled. We are closing in and we are summing it up. There are some exercises that you can look at to start working with PREMIS metadata. I suggest that you print them out. You have the solutions at the same place where you have the exercise itself. And the thing that is that we have created, you have seen this a number of times. It's in the beginning of the description of each entity. You have the short list of the different semantic units, if they are mandatory or repeatable and so on. And you actually do have that listing that you can use as your sort of shorthand listing to the PREMIS semantic units. So I would suggest you print that one out. We are updating this list when we do changes, and we'll present a new version of PREMIS. So it's something that's of extra help for you as a user. Will be mostly will be a really aid for you when you do the exercises. The exercises themselves are on Zenodo. On the first page for the object entity, you need to find the different object types. The one Elle was talking about when she described the object categories and object types there. So take a look and see and discuss. It's good if you can sit with someone else to do this, but you can also do it on your own. And find the different objects in the image. Then for the rest of the pages, you need to fill out your semantic units. using the text you have. It's the same for the events, agents, and rights entity. You have the exercise and you have the response, a suggestion of the response. You might do it differently. Remember that that's just one way of doing it. And use the first handout. There is also one for environments that you can look at. We haven't deep dived in the environments today because that's a session in itself. But you can get a first feeling of the environments in that exercise. We also have an extra example that you can look at. Many thanks to Eld for having provided us with that one. But there you can see how they are using it for a postcard. So that's one way, more example of seeing how it can be used. It's also described in a paper. And as I said, and I'm repeating myself a lot here, I know that this is just an introduction to PREMIS. There are a lot of things more to learn and to use, but start off with these resources that we have talked about to learn more, and you just need to jump on the train and follow along. Participate in the discussions. I see we have a lot of discussions going on in the chat already, and since we are closing in on the Mentimeter, I'm going to just show you the result of the Mentimeter. So if you stop the screen and sharing for a while for me, or Eld. This is the result we have. It's moving around, but as you see, it's a lot of the things are for the born digital objects. It's for long-term preservation. And yes, this is what we are supposed to use PREMIS for. That's really, really what we have created this standard for. Many thanks for aiding us with this one. It might be used in different presentations later on. Please keep on adding your responses. If you start the presentation again out. So, what I want to really end this presentation or webinar with is that PREMIS is a community standard. We need your examples, we need your questions, we need your suggestions. Are there things in PREMIS that you want us to change? You need to let us know. You need to participate and give the community the aid of making PREMIS even better. And with that, I would say the presentation part is over. I think we have a couple of minutes left, so I think we should actually do some diving into and see if there are open questions in the chat.
Thanks, Karen.
Many thanks.
Yeah, thank you. Can I invite everybody to give all Karen and all the speakers a virtual round of applause, as is customary on DPC webinars. So thank you very much. You packed in loads of information into that. I know you said it was just an introduction, and you know we've just sort of scratched the surface there, but there is still tons. I can see that there have been questions as we've been going, and you've been very good at answering those mostly as we've gone. And I just want to ask Jen, is your question answered? Are you happy? Are you content? Would you like to follow up with your other question?
Yeah, thanks, Sarah, and thanks for a great presentation. That was really interesting, all of you. So I put a question in the chat about which systems are using PREMIS. And I'm interested from the point of view of sort of exit strategies, because we're seeing more of our members or the community now that are moving from one sort of big digital preservation system to another. And obviously you're talking about PREMIS being, helping with interoperability. And I was just wondering if, if all of these systems are using it, and if they're using it in a similar enough way that you can kind of fairly easily move the metadata over from one system to another. I don't know if you've got any kind of anecdotal evidence about that.
I think that it depends on the systems, because they can have chosen different parts. So if the one of the system has only taken fixity and stuff like that, and the other one hasn't, but used some other parts, it can be very hard to transform it. But I would think that usually preservation systems would give you a way to put them into the system in another way, because usually you can put metadata with your data, and then you can format to your own PREMIS metadata and transfer it in that way. So no promises, but I think there would be a way, but it really depends. If they both have fixity, maybe it can, but it really depends on that.
I would agree with Eld, and I think what the data dictionary can do here for you is to follow up on every system is only as good as its active users, right? So you can use the data dictionary, go down the line and see what you're supposed to have in there and cross-check if it is in there, and then map it. Or force your vendor, if it's a vendor, to make the mapping publicly available, or to actually implement export routines, or in the case of open source, contribute to having that included.
That seems very sensible, yes. I think because one thing that came out of your presentation was it's great, the flexibility that's within PREMIS, and I hadn't quite realised the levels of conformance and the different classes, the A and the B you mentioned, and you can sort of pick the bits that you want to use and use them up to a point with some mandatory elements, and that's great. I really like that, but of course there's that balance to be had, isn't there, between how whether you can then compare systems and whether systems are doing things slightly differently as a result. But no, it's really good, really interesting to hear how you use it.
Thanks, Jen, and thanks again to the PREMIS team for your full answer.